The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone. My name is Raf Meersman and I'm happy to welcome you to our FiberPlanIT webinar on planning and design for FTTx networks. This webinar is organized by Comsoft, our company, which is the company behind the FiberPlanIT software. I am myself CEO at Comsoft and have been working at Comsoft since 16 years now, starting with a technical background as a consultant, worked as CTO where I was in the lead of the research and development project for the FiberPlanIT development, and since 2 years became CEO and shareholder of the company. My colleague Luc De Heijn is also co-organizing this, but unfortunately could not attend this session, so in this session I will be presenting this to you alone. The schedule for this webinar today is that I will first introduce you to some concepts, then we will focus on the two major domains where FiberPlanIT is active. That is first strategic planning, where the FiberPlanIT simulator is used, and secondly network design, where the FiberPlanIT designer is a support tool. And in the end we can go through some questions and answers. A few practical arrangements. The duration of the webinar is estimated to be 1 hour. If you have questions, please put them on the GoToWebinar question window, and then according to the time we have at the end, we can treat some here. And if not all questions are treated, we invite you to discuss your questions and your project with us in a dedicated call after the webinar. You will also get follow-up email after the webinar with the content of this webinar, but also a link to schedule a call with us in order to discuss your own project given our inputs from the webinar. Just a few words about the company. For those who are not familiar with us, we are a spin-off company from the University of Ghent in Belgium. We are founded in 1998. And we have a background in engineering with a focus on telecom and more precisely also a lot of experience in network planning. And we have a track record of some innovative software in these domains, whereby FiberPlanIT is our latest flagship, and which is obviously the topic of this webinar today. Before we go into the details of what FiberPlanIT does, just one slide to show you. We have been using FiberPlanIT in commercial projects since 2008, and we have done more than 14 million homes, planned over more than 50 projects in 20 countries worldwide. So, what exactly is FiberPlanIT then? Well, in essence, FiberPlanIT is a GIS-based optimization engine for FTTx networks. What does this mean? Well, as an input to FiberPlanIT, you need to provide some GIS data. This can be streets, address points, but can also be, in case you are looking at aerial deployments, can be pole locations, could be existing ducts, etc. All of this needs to be geographical data, because that will be the basis for any calculation. By the way, on the picture you see also a satellite picture. This is obviously only a background to validate your GIS data, but it's not directly usable in automated calculations. A second input apart from GIS is also a rule configuration, and therefore we have some graphical user interface from FiberPlanIT that allows you to specify the most important rules considering the type of network you want to plan or design. Given these inputs, with a press on the button, FiberPlanIT can calculate an optimized design for your area according to your rules in a fully automated way. and it will come up with this geographical plan that shows you how the calculation proposes to deploy the network. So it shows you where cables are deployed, where flexibility points are located, etc. And apart from that, it also gives you a full bill of material in Excel along with the full cost calculation. So at any time for any design, you have a full view on the components and the costs associated with that scenario. Just to situate FiberPlanIT in the whole planning and design process, well, this is just one possible view of an end-to-end planning and design process, where we say, okay, a company can start with strategic planning. That's like business case analysis and deciding where and when to deploy a network. Once it's decided from a strategical point, you can set up a project and make sure you can manage the whole detailed process. And then you can start designing the first areas in detail. So in order to come up with a to-build plan that then can be given to the construction companies to build it, and that can also be then documented in an as-built inventory. In between the design steps that you see in green, it's also important and often needed to do some field verification, which means taking some initial design results into the field and getting some feedback from the field in order to adjust the design to reality. Now, where is FiberPlanIT in this process? Well, we have two tools based on the FiberPlanIT software. The first one, the simulator, is focusing on the strategic planning. The second one, the designer, is supporting in the whole network design process from initial to detailed or fine-tuned design. Obviously, when you're envisaging the whole process, you need extra components, but we have multiple partners with solutions for several other steps in this process and with whom we are integrated. So whenever you're interested in the bigger picture, we can always provide extra information on that. But for the webinar of today, we will focus on the two FiberPlanIT solutions, being the simulator and the designer. So let's start with the strategic planning stage. So the main questions we are confronted with at this stage are questions like, what type of network are we intending to build or should we build? What is the optimal architecture or technical choice? Where to deploy the network? If we have a large area in scope, we could investigate which areas are interesting and which are not. And also when to start deploying your network. So which areas would you deploy in the first year and which in the second year? That's also an important question strategically. All of these questions can be supported by calculations done with the FiberPlanIT simulator. And the main challenges at this stage is that you want accurate results to make the right decisions, but you also want to do it fast enough because you don't want to spend too much time in the strategic planning stage also. If you look at current methodologies used in a strategic planning stage in order to come up with some accurate and fast cost estimates, you have a wide variety of things that are used in a lot of projects. You can look at other projects with some benchmarking. You can look at Excel-based spreadsheet models. You could design a small area by hand and then extrapolate that result to a larger area based on density statistics. Now, all of these three first ones are rather fast, but the accuracy is really a problem. And we have really some cases where we can share more details on demand, where you really see big mistakes coming up when you approach this kind of problem with this kind of methods. So the ultimate accurate solution is to design the whole area in scope and work out a detailed plan and all the costs associated with it. But there the question is, can you do it fast? And that's exactly where FiberPlanIT Simulator is built for, in order to allow that accurate calculations on the large scale in a short time. So let's now move for the first time to the software itself to show you how this FiberPlanIT simulator assists in this part of the process. Allow me first to say one word about the GIS data that is the basis for every calculation of FiberPlanIT. GIS data is very depending on the country you're in, whether it's available and in what quality it is available. Now, we have done many projects in many countries, so we've found some solutions up to now in every case, but still there is indeed a wide variety of accuracy of available GIS data. We will not go into the details in this webinar because it would take us too far. Again, if you have some concerns on this, we're happy to talk it through for your specific case and see what we can do. And I only just wanted to highlight one thing, that is if you go to openstreetmap.org and you just search for your area, just look for a street or a neighborhood or a city and click through, you can actually check what is available in OpenStreetMaps, and this is just freely available because it's open data produced by the community. And in a lot of areas, this is very good data, and it's also rapidly extending. So it's always good to check again. If you checked before, it can be improved already. And you can also export this kind of information directly, and then it's quite easy. We have a lot of experience in that to filter and clean that in order to be used as a basis for FiberPlanIT calculations. Now let us move to the FiberPlanIT software. I am launching the software, the simulator software, and first of all I will be asked to choose a workspace. So let's start in a new empty workspace, and we are now inside the FiberPlanIT simulator. The first thing we can do is to create an area which we want to use for our cost estimation calculation. Creating an area is easy. We give the area a name. This is now an example of Ghent, our hometown, that we have a small demo of. And then we are asked to browse to the files that will define, for example, the demand points or the building locations in this area. Now again, as said, this can be something that you have prepared or that came from some sources on databases with addresses and whatever sources you may have available. And it can come in many formats, like even an Excel file with a list of addresses and their XY coordinates, or shape files or GML files, etc. Let's suppose the Excel file here contains the definition of points, and let's suppose we have a street centerline layer cleaned and extracted from OpenStreetMap. And then we can add some optional data like a fixed central office location to be reused, existing pipes if available, which means, for example, ducts with some free capacity that we could consider for a deployment, or street poles in case we allow some aerial deployment as well. We can also specify some basic geomarketing data, like a time frame we will look for in terms of revenues, and, for example, expected adoption and monthly ARPU for different types of end users. And then we can parse or create the area, which means all the GIS data sources will be combined by FiberPlanIT, and we will get this preview that shows us the area we have just created and gives us some statistics on the density and on the number of living units, etc. So now we have a GIS area created, ready for a calculation. But as said, the second thing we need are some rules and material. So I can also create a new rule set here. Let's suppose we are now looking into a PON architecture. I can choose the currency, and I can start from a standard demo rule for PON, for point-to-point, for hybrid, etc. There are some standards available. And then I create this rule set with different panels where parameters can be specified. So for example, in a PON, we can go and select the split ratio that we want to use for this network. Also very important here is that we can specify the average cost per meter for creating a trench. For example, suppose 20 meters along the street side and 50 euro per meter for crossing a street. In the second panel on demand, we can easily change the foreseen number of fibers per home. For example, let's suppose we want to terminate by default 2 fibers per home in this scenario. Other important parameters along others, I'm not going through all of them, but for example, you can specify a certain capacity of your distribution points. Let's say you can go up to 60 homes on one distribution point in your network. Allow me also to say that we are using a terminology here with drop distribution feeder, which is quite common in a lot of countries, although this is also completely configurable and flexible, so you could add extra layers or change names. It's only just a hierarchy of fiber layers within your access network. And in the feeder layer, for example, well, you can also choose different aspects like how are you deploying your underground cables using, for example, microducts with air-blown fiber and then microduct bundles of different sizes. And you can even go and change some pre-configured strategies, which would take us too long, but there's more advanced differences between strategies that you can select. So you can save all these changes according to your wishes and create a rule set like that. And then we are ready for a first calculation. So now we can create a new simulation and we choose our rule set that we created to be applied to our area. And we launch the calculation. So for this area, which contains about 860 homes, the calculation will take about 10 to 15 seconds. And it runs just here locally on my own PC. So there's no special hardware involved or anything. It's just the whole calculation running here. And as soon as it's ready, it will show us the result, which gives us an insight for this area on the total cost per home passed, cost to activate an individual home in this configuration, a total cost, and an indication of some revenues. But that's not all. Just this summary, you can also click through to the GIS data, and then it's opened. Well, in this case, the GIS data is visualized inside Quantum GIS. That's just an open source GIS tool that you can freely download from the internet. But in fact, we are just producing standard GIS files, so you can visualize them in any GIS tool. And this project or these files give you an insight on what has been calculated. So it's not at all a black box. On the contrary, you can even zoom in and see on a street level and an address point level what has been calculated, and even go into more detail. For example, if I click on a segment of the green line, which are the distribution cables, I can see how many fibers and how many cables of different fiber sizes are installed in that segment. Same with distribution points, for example, where you can see how many homes are connected to one distribution point, etc. So you can verify what has been calculated, that it's according to your expectations, and so that it's a very transparent result. But apart from the GIS output, you can also click through to the bill of material, which will open in Excel, and which gives you, apart from some inputs, the overview of the main cost numbers and revenue numbers, a breakthrough into the different parts of your network, not only from home to feeder, but also differences between homes passed and homes activated costs. So you get a lot of insight already. And in fact, this is only just a summary of the whole detailed bill of material that will exactly list for you the total number of meters of trenching, total number of splitters, splices, cables, ducts, etc. All the components associated with your architecture. And you can even get this bill of material per distribution point, so you can also compare individual distribution points in terms of bill of material and costs. So that is the first calculation. Now, if we want to decide which architecture to apply, we would be interested to make variations of these rules, and that's very easy. I can, for example, check if I only deploy one fiber per home. Well, I can just duplicate my previous rule set, create a copy, and just go into the demand window and change 2 to 1, save, and create a new calculation, and I will get the result for the one fiber. Now, you can do many simulations like that, so let me just open a new instance of the simulator with the prepared workspace where I did this kind of calculations already. So you see here what has been done is, apart from the PON rule set, we have created one fiber scenario, centralized splitters, point-to-point scenario, but also a PON optimized, for example, which in fact is created by playing with different parameters and applying them always and looking what works best for our area. And you see, for example, there is already some more advanced complex splitter schemes where we are deploying multi-stage splitting. And depending on the amount of fibers in a building, we consider even to put different splitters inside a basement. We have been playing around with the capacity of the distribution points in order to come up with the best value, etc. So all of these things can be played with and can be investigated which rule set gives the best results, because applying them all to our area gives us immediately an overview of all the different costs associated with each scenario. We can compare the graphical files and we can compare the bill of materials. And of course, if you copy paste this output total cost for each scenario into Excel, you can also analyze very quickly what exactly is the extra cost for a point-to-point configuration in this area, as opposed to what's the cost saving from going to one fiber. And this allows you to make decisions whether it's worthwhile to get that saving or to take a more expensive option. You can very accurately estimate what the impact of every choice is on your costs. So this gives you an insight on the technical aspects. If we talk about deciding when and where to deploy your network on a large scale, there's another interesting way of using the tool. That is, you have a fixed rule set and you apply it to either a very big area or multiple big areas, so that you can come up with an analysis and a comparison of costs per area. Now, this is an example. I will go through it quite quickly because we only have 1 hour for the total. But again, if this is of interest for you, we can share much more details of this type of calculations. So just as an example, we have a certain rule set. We have in this case a large area of 23,600 living units that is defined in the same way, just by creating a bigger file with demand points. And in this case, we also have a geomarketing file, which actually defines on a neighborhood level where high and low potential areas are, based on, for example, type of families living in a certain neighborhood. And having this kind of input allows us to do a calculation for this whole area. So we can see the total cost for this area and an expected total revenue based on this geomarketing data. But what's even more interesting is on the GIS output, we can also visualize a kind of a heat map where we see, for example, in this case, the green to red dots are the locations of distribution points for our complete area, and we see them ranked at this moment from cheapest being the green ones to the most expensive ones being the red ones. And you can see, in fact, here is in the north is some cheapest area. Most expensive is obviously on the west side. But this is purely from a cost perspective, linked to the costs per DP. But having geomarketing data allows us also to bring up another heat map, which is a break-even classification. So this does not only look at the local costs for deploying, but adds also the estimated adoption and revenue figures over the years, and will give us an indication of a payback period for your investment, so the time you can break even more or less in that local situation. And in this example, where there was actually some either low potential area in the north linked to the type of families living there, while there was a much higher potential in the south, you see in fact a switch from interest on the cheapest, that it's not necessarily from a return on investment point of view the most interesting area to deploy. So this kind of analysis can help a lot to make the right decisions on which areas to focus on first and get the quickest revenues and earnings, and in this way maximize your overall return on investment. So that concludes our brief demonstration of the FiberPlanIT simulator. We have shown how to compare technical scenarios very quickly in order to find the best one that will minimize your costs, or at least know if you take a more expensive option what you're paying extra. And we have also shown that you can compare areas to make the right deployment choices on where to go first. And as such, we have made the whole strategic planning smart, fast, and easy, which is our promise with FiberPlanIT. Smart because we've been able to produce reliable and transparent cost and revenue figures based on these GIS-based optimized calculations. Fast because you can really do it on a large scale, even a national scale. We have done several projects, and an average city, you could do one calculation in about 1 hour. So you see, if you run it on multiple PCs, you could quickly scale up these kind of calculations and make a full heat map of a whole country even. And we've also made it easy. You don't need to be a full technical expert to get some first expert results in this stage of the process. And overall, as such, we are able to optimize the strategy and maximize the overall return on investment of the whole project. A final word on this simulator. It's a very unique solution, especially if you compare it to all the typical methodologies used in this kind of early stage planning, because a lot of methods will offer quick solutions, quick results, but will not be very accurate. And we have examples of a 30 to 50% mistake by using some extrapolations, for example. Other methodologies, like maybe making a detailed plan mostly by hand, will give you high accuracy, but it's not scalable. It's not scalable to large areas in this stage, but for example, also not to work out 5 scenarios if you have to do it by hand each time again. And that's where FiberPlanIT really offers this unique combination of having the GIS-based accuracy in combination with speed and scalability and a high flexibility to produce or to specify different rule sets. Okay, now our strategic planning stage has been finalized. We can move to the next stage, which is the network design stage. So we have decided now where we want to start deploying, and now we want to generate a to-build plan for this first area. So we want to know which homes to cluster around the flexibility point, where to put this flexibility point, which can be, for example, a street cabinet, and how to route the cables between the cabinets and the homes, or between cabinets and a central office. All of these kind of questions, the designer is an ideal support tool in order to support a planner in evaluating options and suggesting optimal choices. The big challenge here is to do it in a cost-optimized way, but still be field-proof, with which we mean if you do pure cost optimization and you say the ideal place for a cabinet is a certain location, you still need to verify whether you can put it there. Because if it's not possible to put it there, you have to pick another location which will be field-proof, so it's feasible and practical, but that it's still as optimal as possible. And it's this challenging combination where the designer can assist you. Why is cost optimized important? Well, we have several cases where we have worked out this kind of a proof of concept or comparison. If you have a certain area and you ask for a design given a certain set of rules, suppose you give it to 3 planners, what you will see is typically chances will be high that you will get 3 different plans, 3 different designs of your area. And each design may look at first sight as reasonable and good. Yet, the costs of each design can be significantly different. So in this example, for example, there's one is the cheapest, the other is 3% more in deployment cost, and the other one is 5.6% higher. While at first sight, it's very hard to estimate or to guess this. So this already gives you a feeling for a manual planner to make a cheapest design is impossible, just because the human mind cannot consider all the combinations of costs that are involved, and making decisions will always happen with a local focus and not with a full view on the whole area that you are designing. So there's a huge potential here to really find the cost optimized solution. But like we said, it also needs to be field proof. So you can decide that it's an optimal location for a cabinet here in this example, the orange dot there. But if in reality someone takes this to the field and says, no, we cannot put it there, we have to move it to here, then you also need to be able to adjust your designs. And this is also where the designer can come in. So if you have this kind of redlining, for example, that comes back from a field survey on the initial optimized plan, you can give that input also to FiberPlanIT, and it will re-optimize the whole network considering those new inputs. And this is important because it will still optimize the whole network, the whole area, and not do some local changes from an initial plan, whereby you can easily lose a lot of optimization if you do it like that. So let's now go to the software itself in order to show how the designer supports these answers to these challenges. Before I go into the designer, let me also say that in this stage we are talking about detailed planning, and this means that a lot of users at this stage will also work with tools that will allow them to document the whole network, to introduce labels, to introduce splice plans, etc. And so a whole database inventory system for the network is often the environment where this stage of the process is being executed. And FiberPlanIT is also integrated with several of these environments or tools in order to work smoothly within the whole process. And so that's part of the solution. But I will demonstrate the designer now in a kind of standalone way, with which you can do the full design exercise, but it will stop at the time you are happy with all your structural decisions, and then you would have to take the results to the inventory in a manual way. But the functioning is the same whether it's integrated or standalone. So to demonstrate it, I will go into Quantum GIS, where I can demonstrate the standalone solution. And we have an example area here where we basically start from the same data as we had when we looked at the input data for the simulator. So we have points which represent buildings, we have streets, center lines, and for example on the points you also see now the house number is visualized. Just to show you, it's actually different attributes are available. You see street names, you see house numbers, you see the number of homes, so that in case of a multi-dwelling unit you will see here the amount of apartments or living units within one building documented. And then a first set of actions that FiberPlanIT supports is actually here. So the toolbar here is the FiberPlanIT toolbar on the left, and the first set of buttons allows you to do some automation in the data pre-processing. For example, create trenches. If you press that button, FiberPlanIT automatically creates a skeleton of possible trenches on the left and the right side of every street, and also considering the street width that you can associate with every street. So for example, a small street here, you can give it a width of 2 meters. Then FiberPlanIT will only generate an option to put a cable on 1 meter to the left and 1 meter to the right. While for other streets, it can be 6 meters. Then it has some options to put a cable further away from the center line. The next step is that you're able to connect the address points with the street sites. And this you can do, for example, with a dedicated drop, or you can also share a drop point amongst two buildings. If you do that, automatically FiberPlanIT will create these drop edges for you. Let me zoom in a little bit. And so suggest you which buildings you might take together on one access point. And at this stage, it's also important, well, you can add satellite picture. So for example, if I add a Google satellite here, I can also already verify some of these decisions, and I could easily change whenever I think a certain way of entering the building is to be done in a different way based on the satellite pictures. Obviously, the field survey will be the ultimate check of what's capable, but from a satellite you can often already receive a lot of information as well. A next step that FiberPlanIT helps you with is to create some candidate crossings. If you press that button, FiberPlanIT generates for you an extra layer, and I'll take away the satellite to visualize it more clearly. So it gives you a set of candidate crossing places between left and right side that will be offered to the tool as candidates, and where the tool will decide which ones to take. So don't be confused that all of these brown lines for the moment, they are not going to be used. It will only be the ones that will be needed to produce a cost-optimized plan in the end. But it's an important differentiator between FiberPlanIT and other tools, that you can give as much freedom as given here. So we are not deciding on where to cross the street. We are offering all the options so that the tool can take the best one from a cost optimized perspective, where a lot of other tools will ask you to almost already decide on this manually in the preparations of the data, and then obviously will not be able to use all the optimizations that are available in the area. Nevertheless, from the candidates, again, you can choose to modify things. For example, suppose you have a street here in the middle now where you know crossings are very difficult or impossible even. Well, I can select them and I could either delete them, for example, if we're sure there should be no crossing here, or we could give them a different subtype, specifying a subtype, for example, that it's with drilling or that it's a more expensive crossing. And so then we can also associate higher unit costs with it. And then the cost optimization will consider that again when optimizing the plan. One other point that is not included in this demo is if you consider aerial deployments, you can also get some assistance from FiberPlanIT to create aerial connections and drop connections starting from pole locations. And you can even create some poles if you don't know the pole locations or you want to deploy new poles. You can also create candidate pole locations with FiberPlanIT. So having produced this set of data and having fine-tuned it to the maximum extent in the back office, we are ready for a first calculation, and that means we can save our area and process this whole set of pre-processed area to be ready for a calculation. So this is now ready, and similar to the simulator, here as well we are able to specify and configure our rules. So again, we can go into the details of all these parameters, but for now you will see, okay, there are the same options more or less. So we can specify unit costs for trenching. We can differentiate between these different types if we want, how much it is depending on the subtype of a line, and all this kind of aspects that can be configured. So having fixed our rules, by the way, normally the rules will have been fixed because we want also some uniformity. So normally there is not a lot of playing around with parameters at this stage. But having fixed those rules, having prepared the area, we are now ready for the first initial design calculation. So I press the Calculate Network button here, and it will start calculating for this area according to our rules how the network would look like. So this is now an area with a few hundreds of living units, and it will calculate now again locally on my PC in a couple of seconds almost to produce an initial design for the area. Now the initial design will give you a view similar to the simulator again, where you can check what has been calculated and how cables are routed. What's different already as opposed to the simulator is that there's a lot of extra information. For example, the distribution cables are now, if I click on a segment, you will see all the individual cables that run through the segment, and you can visualize them one by one, where they are going to and which granularity they have in terms of number of fibers. You can, for example, also visualize, and that's automatically generated, the polygons that group the homes around one distribution point. By the way, you also see it by the color, but the polygon has an extra added value because you can now also start changing these polygons. So whenever you say, I want to investigate whether it's not interesting to maybe take another decision in terms of a cluster, I can go into this cluster layer that was generated. I can adjust the clusters just by adjusting the polygon. Let's say, for example, we want to take out these 4 blue points from the blue cluster and add them to the pink cluster here. And for example, we could do a similar switch in the bottom here, where we can extend the yellow one on the same street side. And a planner may say, I would have done it like this. I think this is more convenient, so I want to check what this will result in. So we can save these changes, and we can just recalculate. And now, given that we have been changing this and imposing these changes in the new calculations, FiberPlanIT will consider our manual changes and will re-optimize given these forced changes. So being recalculated in this area, now we see it's finished, and we see a warning A warning because it says our adjustments have resulted in 2 clusters which are bigger than the indicated cluster size of 80, namely one with 82 and one with 84. It's cleared so that my adjustments actually violated my own rule, and I may be willing to take that violation occasionally if it saves me some money, but obviously the tool cannot take the responsibility to start breaking some rules. So this is also a clear example where a planner still needs to add his value because he can decide whether it makes sense to break a rule slightly, knowing that a cabinet, for example, could accommodate 96 homes, but that the free 16 could be reduced a little bit if it saves a lot of money. And this kind of analysis can be done quickly. So we see the completely re-optimized network considering the changes of homes on a cluster. And we can also access each time for each calculation the same bill of material we've seen before. Or another way of looking at things now is I can open the state manager, and in the state manager I can see the last calculation I've done, which is this half minute ago, and the total cost being 460k euro, and I can actually compare it to all previous calculations, and where in this case you will see the impact of my change is actually very, very small. So you might wonder in this case whether violating the rules actually makes sense because it doesn't influence the cost a lot. In other cases you might find even a higher cost and then decide to return. So when I go to a previous state, I can always reload that state and say, okay, so my change was not as good as I thought it would be, and so I can return or revert to my previous state. You can do similar things with things like the central office location. So I can just, you see a central office location here, but suppose I have so first of all, you could also just leave a central office location open, in which case FiberPlanIT will suggest an optimized location. But you can also fix it, like here on an existing location where the user says, here I could position one. But if you have also an alternative, you could just pick it up, move it to an alternative location, save it there, and again recalculate, in which case now, okay, my clusters and distribution part will be same because I didn't change anything, but my central office location now has moved from a northern candidate location to an eastern location, allowing the full recalculation of the whole network given this new input. And we will see when the results are ready that the blue lines of the feeder are now, of course, going to the new location. And we can again look into the comparison of this new result and see what exactly, so now we are at 464 as opposed to the 460 we had with the northern location. So we can see 4,000 euro extra for this location. Maybe that is not even that much of a problem if that location is better in terms of costs for rental or in terms of accessibility or whatever. So this gives you a first preview. There's obviously much more possible, but gives you a first preview of how you can use the designer in order to produce a first initial design and also to fine-tune that design based on things you want to try out, alternatives you want to try out at every stage of the plan or design. And then there is one more thing here that is very useful. That is, apart from the kind of changes I've been making up to now, you could also want to verify whether in your example, a certain location, for example, of a street cabinet is possible or feasible to put that cabinet there. So, for example, if we consider a random cabinet like that one, well, what I can do is, if you have in your area Google Street View available, I can just click on this location with the white arrow of Google Earth. And doing so will take me automatically to Google Earth, where I will be brought to my design. And I can see where the arrow is, so I can zoom in to this location. So you see both the result in total and my location. And if Street View is available and I zoom in further, I can actually check whether this location is possible. And okay, this seems very difficult with the doors and windows there to put a cabinet there. So I can have a look around and I can look for a suitable location. Maybe I can put it somewhere here or here, and then decide like that what could be an alternative. And changing it here, we've shown before, is very easy. So if you have an alternative location, and again here adding a satellite to help you in positioning it, again is very easy. And once it's on the new location, you can again run it and re-optimize the whole design with your new location and see what the impact is of this change in terms of your total budget. So that concludes our demonstration of the FiberPlanIT designer. We've shown the automated and optimized initial design capabilities with a lot of options and candidate places to put cables offered, and the tool will decide which ones are the most interesting to use. And we've also shown the capabilities of fine-tuning a design, considering input from the field or input from the planner himself, who want to try out alternatives very quickly and compare them with the initial or alternative options he has considered before. So in this way, again, we've made the design process smart, fast, and easy. Smart because we have been able to save on deployment costs, and we've been proving this in many cases that savings between 4 and 8% are realistic compared to manual designs or semi-optimized results. So there's really a big gain if you compare it also to the total budget of the deployment. Fast, obviously, because it increases the efficiency of a design team. You can very quickly also try out alternatives. It depends a lot on the local situation. We have cases where we have been able to double the efficiency, but even go up to 10 times if it's compared to full manual design. And it's also made easy. You have your rules, so you are ensured that your designs are uniform, or you are also informed when you have a violation. And it's also aligned with the real field conditions, and still it's not losing the optimization that comes from the calculations. So in the end, we are able to produce plans that will lower the costs while increase the quality of the designs. And again, this designer is a very unique solution, unique compared to other tools, because many of those other tools on the market will either focus on automation, but will then not have the real optimization efforts, especially not if you offer all the options, for example, in terms of crossings. You do have tools which also focus on optimization, but then there's always a challenge to also adjust to field conditions, which may not be optimal situations. And it's really through this combination of capabilities that FiberPlanIT can offer a good solution here, combining automation, optimization, and adjusting to the field. So that brings us to the end of our webinar. We have shown you the FiberPlanIT software, the latest version, and its unique character to make planning smart, fast, and easy. It's a proven solution with more than 50 projects and 40 million homes planned. I also invite you to visit our website, FiberPlanIT.com, to see some customer references and testimonials, and we have more of those available, so always happy to share some of that. And in the end, with our solution, we can bring a lot of value, first of all on saving costs in deploying, in planning, and in operations afterwards by making more uniform plans. We are able to increase revenues because of an optimized choices of areas to deploy and a quicker time to market. And we can increase the quality through the accuracy on GIS level and the uniformity of designs across teams. Thank you very much for your attention. Just one word on the next steps after the webinar. So you will receive a follow-up email in the coming days, where you will also get access to this information, including the recording of this session, so you can share it with other colleagues or interested co-workers. And you will also, in the email, have the option to schedule a 30-minute call with us to review your own project directly with us, see what are your challenges, see where we can help, and see what are possible next steps in a way of working out maybe a proof of concept or a detailed offering. So this will be offered to you, and we really encourage you to take advantage of this. You will see through the link that is on the bottom of this slide. If you click on that from the email, you will be able to choose your preferred time slot and give us your giving your phone number, and then we will call you at that time to have this initial discussion. So again, thank you, and we have a few more minutes left in which I'm happy to consider some of the questions that have been coming in during the webinar. So I see a question here on the capability of the software to compare different options. Different migration scenarios, like going from an FTTx that can be to the curb or to the building up to the home, which can be very difficult. This is a very good question, because indeed in a lot of cases there will be not a mass deployment, and it takes some time, and you can also look at different market segments that you could be targeting. And in fact, we have done several consulting projects where we have been using the tool to also look at this kind of phased rollout scenarios. These phased rollout scenarios would, for example, allow you to identify first some antennas, some businesses, add some public locations, and then add residentials. And then you can simulate if you produce a design for the complete community, and you would first deploy only the infrastructure needed for the high priorities of public buildings, antennas, etc. But you also put in all the equipment to extend easily later to the residentials, for example, what that does to your whole investment plan and what it does to your overall budget. But this is not something that is immediately available in the tool, so it is some more, let's say, custom use and more advanced use of our calculations. I see another question on the possibility to generate also splicing plans or sheets. This is something by default that is not done with the FiberPlanIT designer. We do have some, again, custom configurations where it can be done, but it's always a bit case by case depending. And also, like I mentioned in the beginning of the designer demo, in a lot of cases we are integrating with tools who have those capabilities of generating splice plans, and in that case it's very easy, because automatically our output can be loaded in those systems and they can generate the splice plans automatically. So together with some partnering tools, we can offer that solution, but by default it's not a capability that is directly within the FiberPlanIT designer as an option. We have 1 more minute, so I'm just looking for a final question. There's a question here on, is it possible to compare different splitting strategies, for example, centralized, distributed, cascaded? Yes, for sure. Within the graphical user interface and the specifications of the rules, you can actually configure the complete splitting strategy, including saying that for certain multi-dwelling units, as of a certain number of living units, you could specify to put splitters in a basement of a certain split ratio, and to combine that cascaded with splitters in distribution points or in central offices. And you can play with those configurations, so you can also change the split ratios at every location and do some new calculations which will follow those new rules, and so you can completely compare those strategies and those costs. So our time is up. There are more questions, but we will be happy to answer those questions in a one-on-one call with any of you. So thank you very much for your attention. If there is anything further, you will find our contact details, so feel free to contact us. And for now, thank you and hope to hear you soon. Bye.